So yesterday we had an introduction to finding the probability of an event. Today we're going to take a look at something called an experimental probability, which is actually something that we were doing yesterday. I just didn't define it for us yesterday. But with experimental probabilities, what actually happens when repeating an experiment many times. So let's say I flip a coin lots and lots of times. The results of getting the number of heads I have to the number of total flips, that would be an experimental probability. It's what actually happens when I do the experiment. Theoretical probability is what should happen in an experiment. So if I flip a coin 1,000 times, I would expect about half of the time that I get heads and half the time I get tails. That's in a perfect world. Well, unfortunately, we don't live in a perfect world, so that might not happen. So theoretical probability is what we expect to happen or what should happen in a perfect world. Experimental probability is what actually happens when we do the experiment. So we're going to do some practice where we're just finding theoretical probability. Again, what we think should happen if I were to actually do the experiment. So just like I was mentioning before, if I flip a coin has two sides. So it can land two ways. And to get heads, there's only one way for me to get heads. So I'm going to think about 1 out of 2 times I'm going to get a head, or 50% of the time. With tails for a coin, same thing. There's 2 ways that a coin can land. It can either land heads or tails, so that's my 2 ways. And there's only one way that I can actually get tails. So again, the probability of tails is 1/2. Now for our next one, if we think about rolling a die, and remember, die is the singular version of dice. Most of the time when you're playing a game, you're rolling 2 of them, so that's why you say roll the dice. But if you're only rolling 1, it's actually called a die. When we think about it, that die can land as a 1, 2, 3, 4, 5, or 6. So there's 6 ways that die can land. How many ways can I get a 3? Because that's what we're wondering. What's the probability of rolling a 3? And if I look here, that's not a 3, that's not a 3. Oh, that is. Nope, nope, nope. So there is only one way for me to get a 3. So the probability of getting a 3 is 1/6. And just to kind of give that to you as a percent, 1/6 is about 17% of the time. So 17% of the time, we would expect that we get a 3. Now let's take a look at our next one. This one says the probability of not getting a 5. So I want any other number besides a 5. Well, again, that die can land in 6 possible ways. How many ways can I not get a 5? 1, 2, 3, 4, 5. So there are 5 ways not to get it. So the probability of not getting a 5 is 5/6, or about 83% of the time. Me being a math person, I love thinking about the probabilities of these things happening. Whenever I'm playing a card game, like my husband and I with our family, we enjoy playing the game Trouble, and I just think about the statistics and the probability when we don't get those 1s or the 6s to get out and play on the board kind of thing. Okay, so now we're going to take a look at the probability of spinning a spinner. And on here, I think about what's the probability of getting purple. Now, with this spinner, notice that all of the colors have an equal chance of happening. If I look at it, they all have about 25% or 1/4 of the circle. So they're all an equal chance of happening. And that's an important part when you're finding the probability, is you want to make sure that each portion is equally likely to happen. When we think about a coin, as long as it's not a weighted coin, you have an equal chance of getting a head or even an equal chance of getting a tail. Same thing when you're rolling a die. As long as it's a normal die and you're not dealing with a weighted one, each of those numbers has an equal chance of happening. Same thing with this circle. Each color has an equal chance of actually happening because they're the same size. So when I look at it, there's only one section for me to land in a purple. So there's one way that I can get purple, but I can land in 4 different colors. So the probability of me getting purple is 1 out of 4, or about 25% of the time. Let's think about the probability of not getting red. So again, I want to think about how many ways can I not get red? 1, 2, 3. And there are 4 ways, 4 colors that I could land on. So about 75% of the time, I'm not getting red. Now again, these are theoretical probabilities. This is what we would expect to happen in a perfect world. Like if I were to spin the spinner 4 times, 3 out of those 4 times, I would not get red. 1 of the times I would. That's a perfect world. Doesn't happen in an actual experiment, but that's what we'd expect to happen. Now let's take a look at this one. We're going to pretend that we had a die and we rolled it multiple times and we kept track of how many times it landed on each number, and we made a table with it. And so we can see in here that we rolled the number 1 4 times. We rolled the number 3 only twice. We rolled the number 6 6 times. So that's what would happen if we completed an experiment and this was our results. So let's find what's the experimental probability of rolling a 6. So we always want to think about, like, how many times did it happen? Well, we just said we rolled a 6 6 times. So it happened 6 out of how many times did I roll it? So to figure out how many times I rolled it, we need to find our total. And think about the word total. It means that we are adding up all of these numbers. So when we add all of those up, I got 29. Hopefully you guys agree. Hopefully I didn't make a mistake. So there's 6 ways that it did land 6 out of the total number of rolls that we had. And if we could, we would simplify this fraction, but this fraction can't be simplified at all. And I don't remember if we talked about this yesterday or not, but experimental probability, it can be written as a fraction, you can put it as a decimal, or it can be as a percent. Doesn't matter. I'm perfectly fine. Most of my students will always just leave them as a fraction because there's really no need for us to convert them to something else. So you can just leave your answers as fractions. So again, that's what actually happened to our experiment. What would we expect to happen in real life, like in a perfect world, I should say, of getting a 6? There's 1 way on that die I can get a 6 out of the total number of ways that it can land. And I just actually did compare the decimals on here. Our experimental probability is a little bit more than what we'd actually expect to happen in a perfect world. Now let's take a look at what's the experimental probability of not rolling a 4. So how many times did I not get a 4? So I'm going to think about adding up all of these numbers that were not a 4. So I'm going to give you guys a minute to go ahead and do that. And hopefully you guys ended up with that there were 21 times that we did not get a 4. Again, there were 29 total rolls. So here's our experimental probability, what really happened when we did the experiment. 21 out of 29 times, we did not get a 4. Theoretically, we would expect 1, 2, 3, 5 ways of not getting it out of 6 total possible ways that the die could land. And as I just calculated this one, this percent is actually lower than we would really expect if it was a perfect world. So our experimental probability is a little bit low than our perfect world, but that's okay because that's our experiment. We just see what happens with an experiment. Now let's take a look at this one. This one we don't have a table, but it gives us information in that initial sentence. It says a coin was tossed 40 times and heads came up 18 times. So for this one, they tell us the total, because that's how many times we tossed it, and we know that we got a head 18 times. So what's our experimental probability of getting heads? Well, in our experiment, we got a head 18 out of the 40 times that we conducted the experiment. Then we want to go ahead and simplify. If I take a look, I can divide a 2 out of both of them. So my simplified fraction is 9/20. Now, what did we talk about on the earlier today? What is our theoretical probability of getting heads? How many ways can I get a head on one coin? One. And the coin can land two ways, heads or tails. So if I look at these two, they're pretty close to each other. Not exact, but they're pretty close. And not like it matters at all, because an experiment is an experiment. Whatever happens, happens. But this is kind of cool that these two are fairly close to each other. Now let's find our experimental probability of getting tails. The problem doesn't tell us anything about how many tails we got, but can I figure it out? We know that a coin either lands heads or it lands tails. There's no other way that that coin can land. So if it landed 40 total times, 18 of them were heads. If I subtract them, that means we had 22 tails. So now we know how many tails we had. We know how many times we tossed the coin. So my experimental probability starts out as 22 over 40. Same thing on this one. I can divide out of 2 out of both. And so we end up with 11 over 20. And again, that's what happened in our experiment. Our theoretical probability, again, there's one way to get a tail, 2 ways that our coin can land. And again, and that makes sense. We said that these two are pretty close. These two are pretty close to each other if we convert them to decimals and compare them. Again, not exact, but pretty close, which is kind of cool. One thing I will tell you guys, the more times you do an experiment like this, like if we were to flip a coin 1,000 times, our experimental probability will get closer to these halves that we're referring to here. So the more times you do an experiment, the better results and more and closer you're going to get to the theoretical probability. So let's take a look at this one. Now we're looking at a spinner, and I didn't include colors on this one because I know that it's hard for you guys to write down what the colors are for it to make sense in your notes. So here I have just a spinner with different numbers on it. A spinner was spun, and it gave the following results. So it landed on the number 1 15 times, the number 2 20 times, 3 18, and the number 4 it landed on there 22 times. So the first question says, what is the experimental probability of spinning a 1? Again, probability is how many times the event occurred. Well, we know from our results that it happened 15 times out of the total number of spins. So we need to add up how many spins I did. So if I add all of those up, hopefully we all end up with 75. So we had 15 where it landed on the number 1 out of our 75 total spins. Reducing this then, we end up with, let's see, I can divide a 5 out of both of them. So I end up with 3 over 15. And oh, I can divide both of those by 3. So I end up with 1/5. So my experimental probability, we got the number 1 on our spinner 1/5 of the time. That again was our experiment. In a perfect world, I would expect to get a 1 time out of the 4 possible ways that that spinner could land. Again, perfect world, this other one, so this is perfect world, this is what actually happened. Close, but again, not exactly the same. Now let's take a look here. What's the experimental probability of spinning an even number? So that means I land on a number that's on my spinner that's an even number. So if I take a look, it could land as a 2, that's even, or it could land as a 4. So I'm going to look at just my 2s and just my 4s. How many ways did it land on an even number? Let's see, it landed on the 2 20 times, and it landed on the 4 22 times. So it landed on an even number 42 times. So it happened 42 out of the 75 times that I spun the spinner. And if I take a look here, can I divide anything out of either one of those? Oh, let's see here. I know I can divide 75 by 3. Let's try 42. If I take 42 divided by 3, I get 14. And and then 75 divided by 3 is 25. So experimental probability is 14 over 25. Kind of close to half, a little bit more than half, I would say. Theoretical probability of spinning an even number. How many ways can I get an even number on my spinner? 2 ways, and it can land on 4 different numbers. Simplifying that, half the time I can get it to land on an even number. All right, the rest of the time then is yours to work on the worksheet then for today. Again, you'll be asked to find some theoretical probability, some experimental probability, and then I think there's a question or two that asks you to compare those two.